In this example, we will use the following information to calculate a t-test statistic, a p-value, and state whether or not we should reject the null hypothesis based upon the significance level. So the first step is to calculate our test statistic. So t will be equal to x bar minus mu naught all over s over the square root of n. This is equal to 14 minus 12 divided by s over 7, change that up, 7 over the square root of 30. This will be equal to 2 over 1.278. This means our t-test statistic is equal to 1.564. So once we calculate the test statistic, we should get our p-value. And this will be a two-sided p-value because we have a not equals in the alternative. So the first step is to find our degrees of freedom, which in this case, our degrees of freedom will be equal to n minus 1, which is equal to 30 minus 1, which is simply just 29. So if we find that on the t-table, go down here and find our t table with degrees of freedom of 29. If we scroll across the row to find where our test statistic falls, it falls between 1.311 and 1.699. So 1.564 falls between these two values. That means if we scroll back up, it's going to be a two-sided p-value between these two values. So the p-value is between 0.02 and 0.10. What that means is that it is greater than 0.10, but it's less than 0.20. And so what this means is we fail to reject the null. Because our p-value is greater than our significance level. Given our test statistic was not exactly equal to then the significance level test statistic of 0.10, this means that we know our p-value is at least greater than 0.10, so we're going to fail to reject the null hypothesis.